Alright, so here we go. We got a baseball, and that baseball is going to get hit, as baseballs are prone to do. And it's launched at some initial velocity. It does not tell us what that is. In fact, that's part of our question. So the baseball flies through the air like baseballs do, and he hits a home run. Everybody's ecstatic. Yippee yahoo. Alright, the ball is hit from 1 meter high. The fence is 130 meters away. And the wall is 21 meters high, which makes the green monster little. Okay, we're looking for the initial velocity, launched at 35 degrees. We need to know the time in the air, and we need to know the speed of the ball just as it clears for a home run. So, here we go. Because the ball was hit at 1 meter high, we can do that math in our head. The wall is 21. The ball's hit at 1 meter high, so we have to change height of 20 meters to clear that wall. We use the kinematics equations. Okay, notice this guy right here. Okay, second kinematics equation. Okay, we're filling out our chart. Watch the magic as we fill out our chart. We know some things. By the way, we're doing vertical. Notice the Y direction. Okay. Oh, let's do, I don't know, something like this. Okay, this is in the Y direction. We're going to do both directions, but anyway, here we go. Filling out this information rather dramatically, I would say. Ooh, we want in the Y direction. So, we know that that's V naught sine of theta in the Y direction, and in the X direction it's V naught cosine of theta. The final in the X direction is the same, we know that, which means that okay, our acceleration in the X direction is 0. Okay, time we still don't know in either case. So, we've got a whole bunch of information, but we're missing very, very important information. We don't know V naught, and we don't know time. We know some is acceleration, so we're going to have to combine some things. We've got a couple of unknowns, which means we have to have, if we have two unknowns, we need a minimum of 2 equations to solve that particular system. But we have that, so the world is a friendly place once again. So, what do we got? We got the change in horizontal is the velocity horizontal times time. So we can put time in terms of the horizontal distance and the horizontal velocity. We don't know that numerically, but conceptually we do know that it is V naught times the cosine. So we do some math magic. And time is change in position over V naught cosine of theta, which via some more math magic gives our change in y, which is V naught sine of theta. That's our initial vertical velocity times time, and we substitute in what we just calculated for time conceptually. And so we've got this equation. By this, I mean this guy. Okay, so we have this. Notice there are no numbers except the 2 which came with the equation, second kinematics equation. Other than that, there are no numbers. I want you to notice that. We solved it. We did all the hard work by thinking the physics. Alright, so now it's just math stuff. Okay, we know G, and I am going to use 9.8 on this one. Theta is 35 degrees. Change in X is 130. Change in Y is 20. So the only unknown we have is V0. Now, because this is a quadratic, okay, it's a polynomial of degree 2, for you pre-calc folks, if you ask your CAS unit nicely, it will tell you, okay, use the solve function, it will tell you V0 is 41.7. So, we did all the hard work thinking the physics. The calculator did all that math for us. Unless, of course, you like being poked in the eye with a sharp stick and you could use the quadratic formula with all the delta x over V0 cosine theta and all that stuff plugged in. Good luck with that. Me, no. Okay, so now essentially we're done because now we know V0. So we can use the equation we came up with, time, delta x over V0 cosine of 35, plug in the numbers, t is about 3.81 seconds, alright, and so then we use our first kinematics equation, and final velocity in the y direction is V0 sine of theta minus yada yada yada, and so that gives us a negative 13.5 meters per second. V in the x direction we know is V0 cosine, and that's 34.2, and that gives us a vector addition problem. And when we add those vectors, which everybody can, there's a 2 missing right there. That's 34.2. And so when we do that, we've got the square root of 34.2 plus a negative 13.5 squared. So we're finding the square root of that, and that's 36.8 meters per second, which is the speed of the ball. It did not ask you for velocity. All it asked you for was the magnitude of that vector. If we wanted the velocity, then we would have to calculate theta in some fashion, okay, and we could do that. We could do the arctangent of 13.5 over 34.2, yada yada yada, and we could get the direction, but it didn't ask us that, so we're not gonna. So, at this point, we have, yippee, a Yahoo. He's watching you.